araw grade 9 students, I will be discussing in this video the theorems on trapezoids and kites. In this lesson, you are expected to state, illustrate, and prove theorems on trapezoid and kites and solve problems involving trapezoids and kites. Let's have first the pretest. Read the question or statement carefully and identify what is being asked. Write only the letter of the correct answer on your paper. First question, which of the following is not true about the median of the trapezoid? Question number 2. In trapezoid ABCD, side AB is congruent to side CD and side BC is parallel to side AD. If the measure of angle A is 68 degrees, what is the measure of angle D? Question number 3. Given the figure below, if the measure of angle B is 100 degrees and the measure of angle D is 4x degrees, what is x? Question number 4. In kite DEFG, the measure of angle EHD is 90 degrees. What is the measure of angle FHE? And question number 5. Given the kite at the right, EG is equal to 10 centimeters and BF is equal to 4 centimeters. What is the area of the kite? These are the correct answers for the pretest. Before we proceed to our lesson for today, let us have first the recap. Refer to the figure below to solve for the required part. In triangle PSG, A is the midpoint of PS and I is the midpoint of GS. And these are the correct answers. Using the triangle midline theorem, the length of PG is 40 centimeters. Let's have number 2. If PG is equal to 115 meters, what is the length of AI? And again, using the triangle midline theorem, the length of AI is equal to 57.5 meters. Number 3. If AI is equal to 16 and PG is equal to 5x plus 7, what is the value of x? Using the triangle midline theorem, we can have the equation 16 is equal to 1/2 multiplied to the quantity of 5x plus 7. And simplifying the equation further, we can have the value of x equal to 5. The previous learning modules have given us concepts and ideas about parallelogram. There are also quadrilaterals that are equally important as parallelograms, and unlike them, these quadrilaterals have opposite sides that intersect at some point. These quadrilaterals are called trapezoids and kites. Let's have first the trapezoid. Let's trap the trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides of a trapezoid are called bases, while the non-parallel sides are called legs. An angle formed by a base and a leg is called a base angle. In trapezoid ABCD, the bases are BC and AD. The legs are side AB and side BC. With respect to base BC, the base angles are angle B and angle C. On the other hand, angle A and angle D are the base angles with respect to base AD. A diagonal of a trapezoid is a segment that joins two non-adjacent vertices of a trapezoid. In trapezoid ABCD, BD and CA are diagonals. Like triangles, trapezoid has also median or mid-segment. The median or mid-segment is the segment that connects the midpoints of two legs of the trapezoid. In the figure, MS is the median or the mid-segment. And there is a theorem regarding the mid-segment of a trapezoid. The mid-segment theorem of a trapezoid states that the median or mid-segment of a trapezoid is parallel to each of the bases and its length is half the sum of the lengths of the two bases. In the figure, MS is parallel to bases BC and AD. The length of median is equal to half the sum of the bases. MS is equal to 1/2 of the sum of BC and AD. This is the proof of the mid-segment theorem of trapezoid. Let's have illustrative examples. If AM is equal to 5 and SR is equal to 13, what is the measure of HI? Using the mid-segment theorem of trapezoid, we have HI is equal to 1/2 of the sum of AM and SR. Substituting the given details, we can have HI is equal to 1/2 times the sum of 5 and 13. Simplifying this, we can obtain the length of HI which is equal to 9. If AM is equal to x plus 2, SR is equal to 10, and HI is equal to 8, what is x? Using the same formula, then substituting the given details, we can have 8 is equal to 1/2 times x plus 2 plus 10. Multiplying both sides of the equation by 2, we can have 16 is equal to x plus 12. And applying addition property of equality, we can have x equal to 4. If AM is equal to 2y minus 5, SR is equal to y plus 8, and HI is equal to 15, what is the value of y? Using the mid-segment theorem of trapezoid, we can have 15 is equal to half of 2y minus 5 plus y plus 8. Multiplying both sides of the equation by 2, applying addition property of equality to simplify further the equation, we can obtain the value of y, which is 9. Now let's have the special type of trapezoid, the isosceles trapezoid. An isosceles trapezoid is a special type of trapezoid in which the legs are congruent and two pairs of base angles are congruent. In isosceles trapezoid ABCD, the legs AD and BC are congruent. With respect to base AB, angle A is congruent to angle B, and with respect to base DC, angle D is congruent to angle C. These are the theorems related to isosceles trapezoid. The base angles of an isosceles trapezoid are congruent. Opposite angles of an isosceles trapezoid are supplementary. The diagonals of an isosceles trapezoid are congruent. The first two theorems talk about the relationship among the base angles of an isosceles trapezoid. This is the proof of the first theorem. This theorem used the definition of right triangles and one of the right triangle congruence theorems to prove that the base angles are congruent. Let's solve examples. Trapezoid MATH is an isosceles trapezoid. If measure of angle AMH is equal to 75, what is the measure of angle THM? Since angle AMH and angle THM are base angles with respect to base MH, then they are congruent. Therefore, the measurement of angle THM is also 75 degrees. Number 2, if measurement of angle A is equal to 100 and measurement of angle D is equal to 3x plus 10, what is x? Measurement of angle A is equal to measurement of angle D. Thus, 100 is equal to 3x plus 10. Simplifying this equation further, we can obtain the final answer, which is x is equal to 30. Problem number 3, if measurement of angle THM is equal to 4x plus 55, measurement of angle AMH is equal to 9x plus 15, what is the exact measure of angle THM? We need to solve for the value of x first in order for us to get the exact measurement of angle THM. Solving for x, we can have x is equal to 8, and using x is equal to 8 of 4x plus 55, the exact measure of angle THM is 87 degrees. Theorem number 2 states that opposite angles of an isosceles trapezoid are supplementary angles. This is the proof of this theorem. Let's solve problems involving opposite angles of an isosceles trapezoid. Trapezoid MATH is an isosceles trapezoid. If measure of angle M is 75, what is the measure of angle T? Since angle M and angle T are supplementary angles, meaning the sum of their measures is equal to 180 degrees, then we can easily solve for the measurement of angle T, and that is equal to 105 degrees. Number 2, if measure of angle A is 100 and measure of angle H is 3x minus 10, what is x? Measure of angle A plus measure of angle H is equal to 180. Substituting the given details, we can have 100 plus 3x minus 10 is equal to 180. We can have the final answer as x is equal to 30. Next problem, if measurement of angle H is equal to 10x plus 15, measurement of angle A is equal to 111 minus x, what is the measurement of angle A? We need to solve first for the value of x. Since angle A and angle H are opposite angles, then the sum of their measures is equal to 180. We can obtain x as 6. Measurement of angle A is equal to 111 minus 6. Thus, measurement of angle A is equal to 105 degrees. The third theorem for isosceles trapezoid is the diagonals of an isosceles trapezoid are congruent. This is the proof for this theorem. Let's solve examples involving the diagonals of an isosceles trapezoid. Trapezoid MATH is an isosceles trapezoid. If MT is equal to 10x plus 7 and HA is equal to 8x plus 15, what is x? Since MT and HA are congruent, then their measures are equal. 10x plus 7 is equal to 8x plus 15. In applying addition property of equality, we can have the final answer for x as 4. Problem number 2. If HA is equal to 6x plus 7 inches and MT is equal to 7x minus 9 inches, what is the exact measure of HA? In solving for x, x. X is equal to 16. Since HA is equal to 6x plus 7, we can have HA is equal to 6 multiplied to 16 plus 7, and we can obtain the length of HA, which is equal to 103 inches. Now let's discuss the other type of quadrilateral, which is the kite. A kite is a quadrilateral with two pairs of adjacent sides congruent and no opposite sides are congruent. In other words, it has two distinct sets of congruent adjacent sides. In kite ABCD, side AB is congruent to side CB and side AD is congruent to side CD. These are the theorems related to kite. The diagonals of a kite are perpendicular. In the figure, AC and BD are diagonals. AC is perpendicular to BD at point P. The area of a kite is half the product of the lengths of its diagonals. In formula, area is equal to 1/2 of the product of diagonal 1 times diagonal 2. And based from the figure, area is equal to 1/2 the product of diagonal AC and diagonal BD. It has one pair of opposite angles congruent. In the given figure, the only pair of opposite angles that are congruent are angle A and angle C. It has one diagonal that forms two isosceles triangles. Diagonal AC cuts kite ABCD and two isosceles triangles are formed, triangle ABC and triangle CDA. Fifth, it has one diagonal that forms two congruent triangles. Diagonal BD cuts kite ABCD into congruent triangles. These triangles are triangle TAD and triangle ECB. It has one diagonal that bisects a pair of opposite angles. Diagonal BD bisects angle ABC and angle ADC. And the last theorem related to kite is, it has one diagonal that bisects the other diagonal. BD is perpendicular bisector of EC, in which AD is congruent to CD. The area of the kite is equal to half the product of the two diagonals. Here is the proof of this theorem. Let us solve problems involving area of the kite. Quadrilateral PLAY is a kite. If PA is equal to 12 centimeters and LY is equal to 6 centimeters, what is the area? Since PA and LY are the diagonals of the kite, then we can use area is equal to 1/2 PA times LY. Substituting the given details, we can have area is equal to 1/2 the product of 12 times 6, which is equal to 72 centimeters squared, and the final answer for the area is 36 square centimeters. Problem number 2. If the area of the kite is 135 meters square and LY is equal to 9 meters, what is the length of diagonal PA? Using area is equal to 1/2 multiplied to the product of diagonal 1 and diagonal 2, we can have 135 is equal to 1/2 multiplied to PA times 9. We can multiply both sides of the equation by 2. The result will be 270 is equal to 9 PA. Applying multiplication property of equality, we can have the final answer for the length of PA as 30 meters. If the area of the kite is 96 square centimeters and PA is equal to 8 centimeters, what is the length of LY? Area is equal to 1/2 of diagonal 1 times diagonal 2. 96 is equal to 1/2 of 8 times LY. Multiplying both sides by 2 to simplify the equation, we can obtain 192 is equal to 8 LY. Applying multiplication property of equality, we can obtain LY is equal to 24 centimeters. Now, let's wrap up what we discussed today. Remember that in a trapezoid, the median or mid-segment is always parallel to each of the bases and its length is half the sum of the lengths of the two bases. In terms of isosceles trapezoid, these are the theorems related to it. The base angles of an isosceles trapezoid are congruent. Opposite angles of an isosceles trapezoid are supplementary. Diagonals of an isosceles trapezoid are congruent. In terms of kite, these are the theorems related to kite. The diagonals of a kite are perpendicular. The area of the kite is half the product of the lengths of its diagonals. It has one pair of opposite angles congruent. It has one diagonal that forms two isosceles triangles. It has one diagonal that forms two congruent triangles. It has one diagonal that bisects a pair of opposite angles. And it has one diagonal that bisects the other diagonal. Let's proceed to valuing. Have you ever experienced flying a kite? Flying a kite is considered as one of the most enjoyable activities, especially during windy months. Sadly, because of our current health and safety situation due to COVID-19, you are not able to go outside and enjoy flying a kite. How do you relate kite flying to real life? Write a reflective essay on how you can compare kite flying to your life. Now let's have post test. Read the question or statement carefully and identify what is being asked. Write only the letter of the correct answer on your paper. And these are the correct answers for the post test. Now let's have activities. And these are the correct answers.